Hello guys, how are you? First of all, thank you for being here watching my session. I'm really glad to be part of this huge conference. I know how big SQL Bits is around the world, and man, I'm really happy to be here. Okay, so let me say hello from Brazil. My name is Vitor. It's Vitor Fava. I am here to share some of my experience, some of my knowledge working with Azure Machine Learning, implementing some AI solutions. So this is our idea today. Okay, guys? So what I'm doing here, my idea, guys, is to give you some kind of introduction about AI, and after this brief introduction I want to show you how we can use Azure Machine Learning Services to implement classification analysis. Okay, I'm going to use an example, a data set that is available for you if you want to try, if you want to play with the same services. Okay, so I'm going to do some kind of analysis on a data set about diabetics patients. Okay, so what is my idea for today, guys? What is our agenda? So as I told you, I want to tell you something about what is artificial intelligence. Okay, what are the technologies? What are the main technologies behind AI? Why today AI is so much discussed, why we have so many things happening on AI, why we have this hype on AI solutions and on AI providers. This is really interesting to discuss, and I want to give you a brief introduction about that, and after that I want to show you a demonstration, to show you a demo how we can use Azure Machine Learning Services to build, to develop, to implement a real analysis, a real classification analysis on a data set that you can download on the internet. Okay, guys? Cool? Are you excited to discuss about AI? I hope you are, because I am. I need to say that I am very excited to bring this today for you guys. I'm really excited, and I'm playing around for some time with AI solutions, and I need to tell you guys, now you can do so many things using AI providers. Okay, I don't want to spend a lot of your time, but I would like to have at least 2 minutes to tell you about myself. So my name is Vitor Fava. I'm from Brazil. Okay, yeah, I'm from Brazil. All right, I'm from São Paulo, here in Brazil. I am a Microsoft MVP, and today I'm working with two areas. I am an MVP on artificial intelligence, and I'm also an MVP on data platform. Okay, this is really interesting. This is really cool for me because I can integrate those areas. Right, you don't have an AI solution without data, so this is really interesting, and I want to show you that. Okay, I'm also the chapter leader for a past chapter here in Brazil, here in São Paulo, Psychomanics. All of you, you are invited to join us if you want. You can check on my slide deck, you can check on the screen. There is a QR code there if you want to join us on our Telegram group. Please do it. Okay, there's no problem. The group is from Brazil, but we already have some people from other countries, and we don't have any problem. Okay, so if you can talk in English, you can ask in English, and this is really good to us. So I'm really excited to share knowledge with you. So please don't hesitate to do your subscription on our channel, to join us here, join our community here in Brazil. Okay, you can also reach me by my email. And you can take a look on my YouTube channel and on my blog. I'm always posting something there. Okay, I am the CEO and founder of a consultant and training company here in Brazil, Vida Database Solutions. We have an expertise to work with data solutions, and we work with analytics, we work with high availability environments, we work on tuning projects, on cloud computing migration projects, everything that is related with data, we can support you. Okay, so please, if you have any questions, just let me know. Send me an email, please. Okay? Okay, guys, so let's do it. Let's dive in on artificial intelligence. The first question that I want to do to you guys is it's about what do you think, what is coming in your mind when you listen to someone talking about artificial intelligence. I'm pretty sure that this is what you think about artificial intelligence, right? Tell me the truth. Tell me the truth, guys. This is something that you expect to see, right? When you read something, when you are discussing with someone about artificial intelligence, I'm pretty sure that this is your expectation. Okay? Yeah, Vitor, my expectation is to have something like Skynet, conquer the world, and then we could have problems. And no, guys, no. This is your expectations, but this is what we have right now. Okay? This is our reality. Okay? I'm kidding. This is a joke. But what I want to say with these examples, guys, is that we still have a large amount of the space. We have enough room to improve our artificial intelligence solutions. And we are doing that. We are doing that. This is my first advice for you on this session. If you are not aware about what is happening, what's going on the AI world, please take a look. Please invest, I don't know, 10, 15 minutes of your day to read some news about that, because artificial intelligence is already there, guys. We already have some huge solutions. We already have some great solutions using AI. Okay? But do you know, there is something that is really interesting, because artificial intelligence, the idea, the theory is it's not new. Hey, really? Yeah, guys, the idea of artificial intelligence, the idea of simulates a computer to make a decision as a human being, the idea of try to understand how our brain is working and simulate that using some mathematical algorithms is not new. The theory exists since 1956, 1954. So when you see that, you can tell me, whoa, really? Since 1956, and today we are on 2020, and just now we have something good about artificial intelligence? Yes, guys. I can tell you, sharing my experience, that I started to see something really cool about artificial intelligence, some good implementations about artificial intelligence, starting in 2014, 2015. So in the past 5-6 years, we had like a huge explosion. We have a boom on solutions using artificial intelligence. And there is a reason for that. In fact, there are 3 reasons for that. We have 3 pillars that they are necessary for you to build a good AI solution. And since 2010, we have something there to use, okay? Hey Peter, but what are those three pillars? Guys, those are the three pillars that we need to build a good artificial intelligence solution. We need data, we need processor power, and we need data models. Okay? And the first thing that I want to discuss with you is related with data. And you can see there on my screen, I have a word that is big data. And I'm pretty sure that this is not something new for most of you. I'm pretty sure that most of you already know what is going on about big data. So, in summary, the idea of big data, guys, is that right now we are producing a large amount of data. We are producing data every second. Okay? For example, right now you can see that I have this smartwatch, and this smartwatch is collecting data about my health, about where I am, about the weather here in São Paulo. So if I try to go for a walk, okay, I will have this same smartwatch collecting data about my heartbeat, about the calories that I'm using on that exercise. So today you are producing data every second of your day, right? All our smartphones are connected on the internet. Most of your day you are using social media. So you can imagine that now we have a large amount of data, and one of the things, and I can tell you that in my opinion this is one of the most important parts of an artificial intelligence solution: data. Right now we have enough data, or at least we have a great amount of data to use and start to do some analysis. Okay? Hey Peter, but why I need so much data? Guys, remember when I told you that the idea of artificial intelligence is to build a model, to build a program, to build a machine, right? That is going to take a decision as a human being. So let me ask you something. How we learn something new? We learn something new trying and practicing. Okay, when you are a child and you do something bad, okay, for example, when your mom says, hey, don't go outside, or don't try to climb that tree, and you do it the same way and you got hurt, you have a new experience, and now you know, okay, I'm not supposed to go outside and try to climb that tree because I could get hurt, right? So you have experience. But imagine we are trying to build a machine, to build a program that is going to take a good amount of data and try to analyze and decide something. How we can simulate experience to a machine, to a program, giving a large amount of data as that experience. So if you have a great amount of data, and this is really interesting, this is really important, you need to have a large amount of data, but you need to have quality on this data. You need to process this data. You need to consume that data. You need to do some cleaning on that data. And to process that data, to do analysis on that data, we need processing power. Okay? For example, hey Peter, I have 1 terabyte of data that I want to analyze. But I have a notebook, or I have a desktop of my company with only 4 gigabytes of RAM. Man, this is not enough to process 1 terabyte of data. You need to have processor power. You need to have the capability to increase your processor power anytime you need. And now we can do it. Again, I'm pretty sure that all of you are really okay with the term cloud computing, right? Cloud computing, it's not a new idea. We already have cloud computing around us for some time now. And the idea of cloud computing is that you can buy processor power. Okay, you can go on a provider and say, hey, I need to process this 1 terabyte of data, and to do that I need a machine with, I don't know, maybe 64 gigabytes of RAM, 1 terabyte of RAM. I don't know how much we could need, but you can just go on the cloud provider, guys, and pay for that, and you have that processor power like that, right? In a few minutes, you have what you need. Okay, it's totally different that if you need to increase your processor power locally. If you need, okay, I have a server on my local data center and now I need to buy some memory. I need to increase my CPU speed, and to do that I need to call to my vendor and ask for that. I need to wait for that, and when I have the new hardware, I need to install, I need to put a new operation system, configure everything. Then to do that, I will maybe need for 1 week or 4 weeks, 1 month, 10 days, 15 days, and you don't have that amount of time to wait. You need to do that analysis right now. So you need processor power right now, in a few minutes. This is where we have cloud computing. Okay, so we already have 2 of the 3 pillars. We have big data, we have a large amount of data, okay? And we also have processor power. The third thing that we have, that we need, are data models. Okay, what is the model that you are going to use to analyze that data? What is your idea? Do you want to do a classification, a regression, a clustering? What do you want to need? What do you need to analyze that data? So with those 3 pillars, we have what we need. We have enough data to simulate an experience to our machine. You have processor power to analyze this large amount of data that you have, and you have data models to implement after you already have that data processed. Okay, cool. So this is why, guys, now you have this huge hype. I like the word hype, okay, on artificial intelligence, because today we can have data, we can have processor power, and we already have data models, right? Okay, so it's easy to work with those 3 pillars. Okay, cool. So okay, guys, and thinking about artificial intelligence, what are the technologies behind AI? What do we have under the AI umbrella? Okay, because AI is a huge area. Okay, AI is a huge area. You have a lot of possibilities. You have a lot of opportunities to work under the AI umbrella. I put here 3 of the technologies that I think are most important. On our session today, guys, what I'm going to do is to focus on machine learning. We are going to build a classification model. So I'm going to focus on machine learning, okay? But I want to bring you a summary about those 3 technologies: machine learning, deep learning, and NLP, okay? The idea of machine learning, it's really cool, right? What do we have when we talk about machine learning? The idea of machine learning, guys, is to have a program, okay, that is going to learn, that is going to take a decision with minimal programming. what I want to say is that we are going to create a machine learning model, and we are going to configure some parameters there for our machine learning model to receive an amount of data, to have an input, to have an algorithm, to have a program that is able to learn, only analyzing the data. Okay? And you are already using that kind of solution on your daily basis. An example that I really like to share with you guys is, for example, when you are watching Netflix, right? Imagine that you are watching a show, and it's a show that you like it really a lot. And after you finish that show and you take a look on your Netflix page, you are going to have some recommendations, right? And in most of the cases, those recommendations are good ones. They are shows that you are also going to like. And you can start to think, hey, how Netflix is able to do that? How they know what I like? And the idea here, guys, it's again related with those three pillars that we were discussing a few moments ago. You can only imagine how much people you have around the world using Netflix. Okay? And Netflix is collecting a lot of data about each one of those users, and then analyzing all that data. And I'm pretty sure that around the world you have some people that they could have the same kind of preference that you have when you are watching a TV show. And they could have, for example, the same age as you, they could live on the same country, they could have the same internet speed, for example. I don't know what are the information that Netflix is using, but Netflix is going to use all the data to analyze and build a recommendation for you. Okay? Right? And in most of the cases, they are going to be right. Another example is Amazon. I like to talk about Amazon because Amazon is a huge company. Everyone knows Amazon, right? But all e-commerce that you like to buy, yeah, this is really interesting. In Amazon, when you are buying something, if you pay attention on your screen, you have those recommendations. Something like a person that buys this product most of the time is buying those other two items as well. This is also a recommendation. Okay? And again, how this is possible? You can imagine how much data Amazon already have. And Amazon is going to analyze everything, is going to do some processing on that data, is going to do some data models, some mathematical models to build an algorithm that is going to do some recommendations, do a classification about that. Okay? And I really like to say, guys, that in my opinion, machine learning is the principal technology about artificial intelligence that is helping us to have this boon of solutions in the market right now. Okay, most of the solutions are using machine learning, right? Most of them are using machine learning. Okay, you have the other two that I told you. You have deep learning, right? The idea of deep learning, it's really interesting. Okay, you could use deep learning, for example, to analyze some videos, to identify someone in a video. You can imagine how cool is that? Okay, I have a great experience here that I would like to share with you guys here in Brazil. I had the opportunity to work on a project, one of the first projects that we have here in Brazil using deep learning. It was a project where we were building intelligence that were doing some analyze on videos. It's about a security, right? For example, if you have a market, if you have a store here in Brazil, it's pretty common. I think it's pretty common there where you live too, right? You have some cameras around the store to know and to see what's going on. But here in Brazil, it's pretty common to have that outside the store too, to take a look what's going on. And the idea of the solution is to analyze the video. And for example, if you have a person going in on your store using a helmet, right, a motorcycle helmet, this is something that could be suspicious. Why you have a person that is going on your store, as entering your store using a motorcycle helmet? This could be for a robber, right? So I worked on that, and that was a great project using deep learning, using computer vision. This is really cool. Okay, to do that, we need a huge amount of processor power, guys. We need a huge amount of processor power. We need to change our idea of using CPUs to start to work with GPUs. Okay, I'm pretty sure that you already know about GPUs. You like to play some games on your computer, right? Or maybe you like to work with videos, to edit some videos. And when we talk about GPU, it's related, right, to the graphics that you are going to use on your computer. Okay, so GPU, it's the main hardware that you need to use to process those kind of videos. Okay, cool, guys, awesome. I have here an example of a machine learning algorithm. Okay, a machine learning algorithm. We could have two kinds of machine learning algorithm. We have the idea of supervised learning and unsupervised learning. On our session today, guys, I'm going to focus on the supervised learning. Okay, I'm going to focus on this supervised learning and to talk about classification. Okay, guys, this is what we are going to talk about. So the idea to use supervised learning is really simple, guys. What is the difference between a supervised and an unsupervised learning? Remember when I told you that to build a machine learning, we need to use data, right? We need to use data to train our machine learning model. And when we are talking about supervised learning and we want to do some analysis, we use a data set, an example of data that already has the information that we want to predict. Okay? For example, imagine that you want to build a machine learning model to predict the price of a house on your area. Okay? So to predict the price of a house, we need to analyze other houses with the same features, the same characteristics that we want to discover. Okay, right? So to build this model, we need a data set, an example of data where we already have houses and we already have the price of those houses. So based on the characteristic of each one of those houses, we can predict or we can generalize a price for a new house, comparing the characteristics, the attributes of this new house with those other houses where you already have the price. Okay? Cool, guys? Okay? Now, Peter, I have some questions. Okay, guys, let me show you. Let me show you something. I'm going to grab that. This is the model that I want to show you. This is the implementation that I already have. I'm going to show you the data set that we are going to use on our test. Okay, so let me open that, guys, for you. We are going to work on a supervised learning using a classification model. Okay, let me just open that. I'm going to import the data. Let me show you. I'm going to import the data from the CSV file. Okay, the CSV file that I just downloaded for you guys here. I already have that one. This is the one that I want to use. Cool. Okay, let me load the data. So okay, guys, this is the data set that I'm going to use with you on our example. This is a data set with some patients. Here you have some attributes of each one of the patients. Okay, and this is a data set that we are going to use to predict if a patient is going to have diabetes or not. Okay, so to discover if a new patient has diabetes or not, what do you need to do? We need to analyze patients that we already know if they have diabetes or not. Okay, so this is what we have here, guys. Take a look. We have, for example, this patient here. We have some information about plasma glucose, blood pressure, insulin, BMI, and we have age, and we have a column here. Okay, a column here, guys. Let me show you. This column, it's a red label to us. So I already know that this first patient, he doesn't have diabetes. And I already know that this patient, this patient has diabetes. Okay? So we are going to use this data set to train our machine learning model. And after this training, our machine learning model is going to be able to predict if a new patient is going to have or not diabetes. Okay, so this is a supervised learning. We have the information already there. We already know some examples of people that they already know if they have or have not diabetes. Okay, this is what we have on a supervised learning. It's totally different when we talk about unsupervised learning. On an unsupervised learning environment, we have a data set, but we don't know anything about that. We don't know what we can discover on that data set. For example, we have a data set of customers from our e-commerce, and I want to create some groups. I could use unsupervised learning, a clustering algorithm to create some groups. So I don't know how those groups are going to be created. I don't know anything about the data. I just want to my machine learning model to analyze the data and create that for me. Okay, can you see the difference? I know that could be difficult in the beginning, but you just need to remember, guys, when you see supervised learning, you are using a data set with real examples, with the data that you want to predict already there. You already have some examples of the data that you want to predict. On unsupervised learning, you have the data, but you don't know why, what you are going to find on that data. Okay, guys? Cool. And our example, guys, I'm going to use a supervised learning, a classification model. The idea of a classification model is really simple. So we are going to split objects based on an attribute. Okay? For example, if you have spam filtering on your email. Yeah, guys, this is artificial intelligence. Whoa, Victor, really? So I am already using artificial intelligence? Yes, you are, guys. Yes, you are. Spam filtering is an artificial intelligence. What is going to happen? You have a large amount of mails, and you have a machine learning model that is analyzing those emails and trying to identify if this is a spam or if this is not a spam. Okay? A classification model is just like that. Okay? You have information that is categorical. For example, is a spam 01, yes or no? Okay? In that example that I was discussing with you on our data set, this patient has diabetes, yes or no? Okay? For example, guys, I have here, if you are going to go to a bank and ask for a loan, you have two options, right? You are going to have the loan or you are going to have not the loan, right? Okay? It's a classification model. Yeah, it's a classification model using a decision tree algorithm, right? So you have something like that, okay? Let me try to do some examples for you. So the bank is going to analyze your credit history. So you have a good one. Yes, I have, but have a debt that is over 1,000. Yes, I have, so you are not going to have the loan. Or no, I don't, so you are going to have the loan. On that side, for example, I don't have a good credit history, but I have a pledge. Yes, I have a pledge. You have some guarantors? Yes, I have, so you are going to have the loan. See, this is a classification one. It's true or false? Yes or no? Right? Yes or no? This is the difference between a classification model and a regression one. Okay? So if you have interesting to know more about regression algorithms, send me an email and let's discuss, let's talk about that. On our session today, I'm going to use only a classification one. Okay? Cool? Okay, guys? I hope that you are good until now, because right now, guys, we are going to see something real. Okay, enough talk, show me the demo. Yes, I'm going to do that. Let's do it. Okay, guys, as I told you, I'm going to use Azure Machine Learning, and to build that, I'm going to use Azure Machine Learning Studio. Okay, Azure Machine Learning Studio, it's a interface where you can build a machine learning model easily. This is not the only way. You can build a machine learning model using Python, for example. You don't need to use a graphical interface, but man, I need to tell you, this is really useful. This is really useful. Okay, so if you don't know about Azure Machine Learning Studio, pay attention right now. Let's dive in and take a look how easy it is to use that tool. Okay, so guys, I already have my model here, and the reason for that is because if you take a look on each one of my tests here, they are already processed. Right, you can see that all of them have this green mark, and I already did that because I didn't want to spend a lot of our time on our session waiting for that, because I don't want to use a lot of processor power, so it's slower to process my data. So I already have everything, okay? But I want to discuss with you what I'm doing here. In summary, what I'm doing is to input some data, and then I'm doing some transformation, processing the data, remember? And after processing the data, I'm doing some analysis using a machine learning model. I'm using two types of regression, okay? I'm using two types of regressions here. And then after that, I have an output that is a prediction about my data set. So let's take a look. Let's take a look what I'm doing here. First thing, I have my data set. This data set is the same data set that you are seeing here, okay? But one of the great things that you can do, and this is really important when you are working with machine learning solutions, is to take a look on your data distribution. I can just right click here, and I can take a look on data set, and I can take a look on visualize, and this is really cool, guys. I can see the distribution of each one of my attributes, my columns on that data set, okay? For example, this is a good distribution. See, this is a good distribution. When you have that bell shape, you can see on this bar graph, when you have that bell shape, this is cool. This is what we call a normal distribution. That is different from this one. See, this one, you have like a huge spike here that could be something we call an outlier, a value that is totally off of the curve. And if this is real, we need to work and we need to do some cleaning on that data. I have another example here for you guys. If you take a look on age, you have the same scenario. You have like a huge spike here, and you have other values for age. So the first thing that we want to do is do some process on that data. We want to normalize that data. We want to bring all the data in the same range. Okay, if you take a look, for example, here on age you have 21, but if you take a look here on diabetes pedigree, you have like a 0.1. So here you have a 21 and here you have a 0.1. See, the range of the information is not balanced. So we need to work with that. We need to bring everyone at the same range, on the same size. Okay, so this is what I'm doing here, guys. What I'm doing here is to apply, is to apply some math operations and do some normalization here, okay? I'm using a log function here to normalize the data, okay, on the column age, if you take a look here. And after that, if you take a look, I'm going to show you this visualize. And you can take a look, guys. This is our age, our original age, see, 21, and this is our age after I used a log function, okay? See, we have the same information. It is the same information in a different format, right? So we have 21 to 3.0. It's closer to the same range that I have on diabetes pedigree, for example. Okay? So what I'm going to do is that treatment on all the columns, and this is what I'm doing here. I'm applying a math operation here, and then I'm doing the same thing here using z-score. This is another method that you can use on the other columns, see? And I'm doing the same thing here. I'm using another method that is min-max on all the other columns. After that, guys, what I have, let me show you. I will show you here after we normalize everything. Oh, let me just go here. Transform a data set, visualize, so you can take a look here with me, guys. And if you take a look, pay attention, all the data now is on the same range. See, 0, 1.9, 0.5, 0.3, minus 0.8, 1.2. See, everything is on the same range. Okay? So after that, what I need to do, I need to train my model. I already have the data. Okay? I already have the data. So if I already have the data, what I need to do now, guys, is to train my model to use that data, and then after that, predict something new. Okay? And when you are building a machine learning model, you need to do a split on your data set. Okay, you need to use a portion of your data set to train your model and another portion to test your model. So you have a training data set, a training data, and then you have a test data. Okay, right? So this is what I'm doing here, guys. Take a look. I'm using a split data task, and then I'm saying that I want to use 70% to train and 30% to test. Okay, so this is what I'm doing right now. Take a look. And here I did something different. As I told you, I'm using two different algorithms to predict. Okay, so what I'm doing is training my model. Take a look. Okay, training my model. I'm using a two-class logistic regression, and I'm using a two-class boosted decision tree. I'm training those two algorithms using my data set, and then I have a score model here. Okay, on that score model, guys, what I have is the prediction. If you take a look, this is really cool. Take a look here, guys. On this split data task, I have two outputs, right? One output is going to be here to train my machine learning model. See, I'm training, and the 30% is going to be used to test. This is what I'm doing here on the score model task. I'm testing my model after I already trained that. I'm testing if everything is working fine. So if you take a look, I can visualize a data set after I tested. And take a look here, guys. Let's take a look here. Let me just do that. And this is really cool, guys. This is really cool. Okay, here, guys, you have the original information here, if a patient is diabetic or not. Okay, and here, guys, we have our prediction. Okay, and if you pay attention, this is right. Okay, the real information is, okay, this patient has diabetes, and our machine learning model is predicting that, yeah, this patient has diabetes, but it's not 100% accurate. If you take a look, guys, here, take a look here on that one. The original information is, yes, this patient is a diabetic one, and our prediction is saying, no, he's not a diabetic one. And yeah, this is going to happen. Hey, Peter, but why? First, because I don't have enough data. I have just a small data set. I just processed a small data set with a few rows. If I'm not wrong, I have 200 rows, 300 rows to process here to use as an example. So if you have a large data set, you are going to have more accuracy. If you have a good data set, you are doing a good job. You could have a good accuracy. If you have a data set that you don't have a good data quality, you are going to have a bad prediction. Okay? Cool? This is something that is going to happen, guys. Okay? Cool? And, well, let me just go back here to show you, guys. And here I have the last one, that is an evaluation model. Let me show you. This is really cool because here I can take a look on the performance, on the metrics of my tests. And I'm using a classification model, and one of the metrics that you could use to analyze if your classification is going good or bad is this graph here, guys. When you have true positive rate here, false positive rate here, and you can see that I have two tests. I already show you. I tested two options of a classifier function. Okay, and you can see that the red one is the best one because it's really close to 1. that one is not good because see, it's really far for 1. So this is one of the metrics that you can use for that. Okay, you have other metrics that you can use. You can take a look here. You have a confusion matrix where you can take a look, and you have more information like accuracy, F1 score, precision, recall, negative precision. This is really cool. Just to give you a summary, what I'm doing here is to take a look on that. See, on accuracy, you can see that on the blue one, the accuracy is 0.7, but when I select the red one, you can take a look. See, you can take a look here. The accuracy is 0.9. It's really better than the other one. Okay, cool, guys. Okay, guys. This is everything that I want to show you. I would love to have more time to discuss with you. I would love to have time to show you more examples. So if you are interested, please don't hesitate to reach me by email. I hope you enjoyed my session as much as I enjoyed to be here discussing that with you guys. It's a huge pleasure for me. I'm really glad for this opportunity. I just want to say thank you for Psychobits for this opportunity, and I want to say something for you guys. I want to say congratulations for you that are investing your time here to watching those sessions. You are the master of your career, okay? You are the master of your career. If you want to be a great AI engineer, if you want to be a great DBA, if you want to be an expert in performance tuning, you just need to study. You just need to focus on that, invest your time on that, go after people that you know could share something with you, and for sure I would love to share everything that I know with you. So if you have any questions about SQL Server, Azure, performance tuning, AI solutions, don't hesitate to reach me, guys. Okay? I really want to say thank you. I wish you all the best. Please stay safe. Okay? I'm pretty sure that we are going to go through this coronavirus crisis, and we are going to have the chance to talk each other in person. I hope to see you on the next Psychobits on 2001. Okay, I hope to see you there, guys. Thank you again. I hope you to have a great conference, and all the best. See you, guys. Thank you very much.